Am I audible?
Yes, you are audible.
So, with the permission of Dr. Ankur Gupta sir and Principal Dr. Narendra Soni sir, I would like to start our today's international. So, good morning, one and all. I am Ms. Kapri Kupade, behalf of PPM's Maharshi Parshuram College of Engineering, Bhubaneswar. Welcome you all to the International E-Symposium on Smart Infrastructure, AI and ML 3 5.0 and Sustainable Infrastructure and Energy for the Future 2025. So this session will start from 17th April at 9:30, like we have joined today, and will conclude at the 18th April 2025, which is organized by BPM's Maharshi Parshuram College of Engineering, Bhubaneswar, and Department of Mechanical Engineering of Dr. Baba Saheb Ambedkar Technological University, Loneri. And the conveners are Dr. Narendra Soni sir, Principal of BPM's Maharshi Parshuram College of Engineering, Bhubaneswar, Dr. Hemant Varhatkar sir, HOD of Department of Mechanical Engineering, Dr. Baba Saheb Ambedkar Technological University, Loneri, and the co-conveners are Dr. Raju Pavde sir, Associate Professor, Department of Mechanical Engineering, Dr. Baba Saheb Ambedkar Technological University, Lonere, and Mr. Avinash Pawar sir, Vice Principal of VPM's Maharshi Parshuram College of Engineering, Bhubaneswar. And the organizing secretary is Mr. Rahul Kundia sir, Assistant Professor, Department of Mechanical Engineering of VPM's Maharshi Parshuram College of Engineering, Bhubaneswar. So, this symposium brings together experts and participants to share knowledge, ideas, and innovations in the field of smart infrastructure, artificial intelligence, machine learning, and sustainable energy. So, I would like to extend a warm welcome to all the participants. So, this theme of the symposium is particularly relevant in the today's world. So, the papers and presentations that will be shared over the next 2 days will provide valuable insights and sparks for the meaningful discussions. So, with honor, I would like to welcome our chief guest, Dr. Ankur Gupta, sir. Welcome, sir. Okay.
Thank you so
So,
much.
okay. So I request our organizing secretary, Mr. Rahul Kundia sir, to address the participants.
Thank you, madam. Respected chief guest, honorable keynote speakers, and distinguished guests, esteemed conveners, dear participants, and ladies and gentlemen. Good morning and warm welcome to all of you at the iSMILE 2025 International E-Symposium. So it is immense honor for me to stand before you today as the organizing secretary of this prestigious event. This symposium marks a significant milestones, bringing together some of the brightest minds and innovators from across the globe to explore the most cutting-edge topics like as a smart manufacturing, AI, machine learning, and sustainable infrastructure, and also energy. So iSmile 2025 is not just a conference, but a platform where ideas coverage, where knowledge is exchanged, and where the future of technology and sustainability is discussed in great depth. We are privileged to have the eminent experts, thought leaders with us today, who will share their valuable insight and research finding how advanced technology can shape our industries and contribute to sustainable development. I would like to extend warm thank you to our distinguished chief guest, Dr. Ankur Gupta, and all our keynote speakers and panelists. Your presence is a testament of the importance of collaboration in our field and to future direction of my smart manufacturing and industrial evolutions. So I must also express my deepest gratitude to our conveners and also co-conveners. So this symposium focuses on the intersection of innovation, sustainability, as well as the future of the industries. With the discussion of smart manufacturing and the integration of AI/ML in industrial processes, the role of Industry 5.0 and sustainable infrastructure. We hope well into the comprehensive dialogue, the foster innovation and addresses the global challenges we face today. We are so very excited to engage with our participants throughout the sessions as your contribution in what will make this symposium truly successful. Your involvement today not only adds the discourse but helps shape the future of technologies will affect the industries worldwide. Finally, I would like to express my sincere gratitude to all volunteers, coordinators, and organizing members who have worked tirelessly behind the scenes to ensure this event runs smoothly. Your efforts are deeply appreciated. Once again, a warm welcome to iSMILE 2025. Let us make this symposium platform for sharing knowledge, fostering innovation, and paving the way for a brighter, and more sustainable future. Thank you, and I hope you have enriching and insightful experience throughout the event. Thank you once again.
Thank you for your words, sir. Now I request Dr. Narendra Soni, sir, Principal of VPN's Maharshi Parshuram College of Engineering, Bhubaneswar, who is the main source of encouragement for our conference. So I request, sir, please address the participants.
Thank you, Bhakti. Good morning to all of you. And my warm welcome to Dr. Ankur Gupta from Jammu, Director, Model Institute of Engineering and Technology. Welcome, Ankur, sir. I am very thankful to you for accepting our invitation and joining over here. Sir, I need a promise from your side. Next time you will be visiting physically to the campus. Keep in mind, sir. We'll be waiting for it.
It will be a pleasure, Sony sir.
Yeah, that's no size of it. So once again, I welcome to all the participants for this event. And I congratulate Rahul and his whole team for organizing this very apt event. It's very fantastic that Industry 5.0, the title of this symposium is very apt. Industry 5.0, the basic theme line of Industry 5.0 is automation with the human intervenence and the sustainability. So it's a very fantastic platform where all of you young talent will be getting an opportunity to share and exchange your ideas and the thoughts over there. So I hope this platform will give a lot of encouragement to all of you, and it will also help to bring up your ideas over there. I hope that the next 2 days of your event will be well organized from MPCOE. We will strive our best to organize this event in a well professional fashion and see the comfort of all, maintaining the time and maintaining the connectivity. Since it is a e-symposium, the connectivity is the most important issue. We are in a rural area. We will try to see the best connectivity is maintained over there. So with these words, I once again welcome to all the participants, Ankur sir, and I congratulate Rahul and his team for organizing the event in a so nicely and well-deserved fashion. Thank you very much, and all the best to all of you.
Thank you, sir. Your words mean a lot for us. So, with the permission of our chief guest, I would like to briefly introduce our today's chief guest, Dr. Ankur Gupta, sir. Actually, this is not possible to introduce him in just few words, but I would like to try. So, Professor Ankur Gupta, sir, is the director at the Model Institute of Engineering and Technology, Jammu. Besides being a senior professor at the Department of Computer Science and Engineering, he has more than 26 years of experience in spanning industry and academia. Prior to joining MIT, he worked as a team leader at Helvet Packard, India at Bengaluru. He has 19 patents granted and 35 patents pending at the Indian Patents Office and over 95 published research papers in international journals and conferences. Professor Gupta holds B with CS and MS degrees with BITS Pilani and PhD from NIT Hamidpur. His research interests are in metaverse, cloud computing, P2P networks, network management, and AI. He is a recipient of AICTE a Career Award, faculty awards from IBM, EMC, and rupees 2.5 crore in funding from government agencies. He is the founder of the International Journals of Next Generation Computing and senior member of IEEE and ACM. He is the inventor of the Performance Insights 360 Quality Analytics Framework for Higher Education Institutions, which receives the Quality Council of India Dear Shaw Platinum Award. the highest award of quality initiatives in India. So I request Chief Guest Dr. Ankur Gupta sir to address our participants.
Thank you for the more than kind introduction, Sony sir, Rahul sir, the organizer, Bhakti ma'am, for giving such a good introduction. And thank you for inviting me again to such wonderful events. I must compliment the institutional leadership and the team that you always organize the most relevant, timely, and the topics are very timely and relevant. That is most important, because when people come for such events, they must go away with some good ideas about future direction, some ideas for their own research work, and it should seed some ideas into their mind. So with chat gpt and other modern tools, it's very easy to figure out what are the major challenges in a particular domain. And I would encourage all the participants to make effective use of chat gpt to figure out what are the bigger challenges that industry will face while they are transitioning to industry 5.0, while they are integrating ai in their operations, while they are also trying to retain the relevance of humans in the manufacturing process. So there is a concept of human in the loop. So when humans come in the loop, then how do AI based systems adjust to the presence of human beings? How do they adjust to the limitations of human beings in terms of the speed at which they work, their cognitive limitations, how much they can process information, how much they can handle the packaging or the manufacturing or the assembly portions in the smart industries. So AI would need to understand humans, and humans would also need to understand AI at a deep level to make sure that this is workable for everyone. The second aspect that I would like to touch upon is the connectedness aspect. That nothing smart comes out of it unless the entire industry, the entire factory is connected to each other. This means that there would be a lot of communication related research that would need to be done. If you want smart manufacturing, you want real time artificial intelligence, you need edge computing, you need time sensitive responses. Because in smart manufacturing, smart industry, you these applications are not delay tolerant by nature, they are not delay tolerant by design. So if a car is being manufactured and the robotic arm needs to precisely come in and fix the doors at a particular point of time, so you need real time ai, you need high performance ai, you need a backbone which supports high performance ai, you need smart, you need intelligence at the device level itself. You cannot have a centralized server which is processing ai requests and doing the analysis and sending back. So the intelligence moves closer to the device. So can you make intelligent robotic arms? Can you have gpus fitted within the robotic arms for computer vision and those kind of things? So you have to look at these aspects. Then the other aspect that is very important is maintenance, repairs, upgrades, end of life cycle. How do you do predictive analytics? What kind of data sets would you need to generate? How can you predict failure before it actually occurs? How can you do maintenance before it becomes a major fault? So predictive analytics is also very important, not a very new area, but applied to machinery. And sometimes you have older machinery as well. How do you make that machinery talk to your ai agents, or you have smaller agentic ai frameworks now coming in? So those kind of things. The next aspect is digital twins, very important. What if you have a earthquake? Can you have a replica of the factory, or you can have a replica of the smart manufacturing on another machine on another location? Can you quickly shift over? Can you use digital twins for simulation? Can you use digital twins for predictive analytics? Can you use digital twins for training and support and those kind of things? So these are very important aspects. How do you create digital twins? How do you make sure they are updated in real time? These aspects would also be useful for us people to consider. The next aspect in all this is explainable AI. So how do you explain why was a particular decision taken by a machine while doing manufacturing? If there is an error, how can you trace where the error occurred? How did the AI algorithm arrive at this final decision? So you need some level of explainability. You need, audit trails. You need a history of how and what data was received, what algorithm was applied, what kind of weights were applied to that particular data, and how was the inference drawn by the AI algorithm. So that's also one aspect that I would be very very interested to explore. Two new concepts which are coming in is when you have so much of AI, when you have so much of processing taking place in industry 5.0, then what about the energy consumption aspects of these AI algorithms? So many AI algorithms, real time data, computation intensive, communication intensive. So the energy requirements for these AI algorithms is expected to be intense. There is a new concept which I recently read about. It's called lazy robotics. So lazy robotics is, do I really need to process this? Can I defer it? I will not do it right now. I will take 2 more seconds to do it. Is the task that I am handling real time? Can it suffer a delay of 2 seconds and still not compromise its accuracy? So these aspects are very important, and there is a term which recently we have proposed. The paper is still under review. It's called lazy artificial intelligence, and we are trying to figure out, can we teach artificial intelligence to learn when and how not to act? So acting is important. When you have data, it will start working and drawing inferences, but we are trying to figure out, in lazy artificial intelligence, can I put it in a pipeline? Can I offload it to somebody else? Can I delay it? Can I combine inputs into a similarity cluster and do cluster based inferencing rather than doing inferencing for each data point which comes in for processing? Can I do inference caching, that I have decided once, and if the similar input comes, I will give the same output without having to do the performing of the AI computations again? So these are very very interesting times. As this domain evolves, I can see that there are at least 10 subdomains where a lot of interesting research work can come through. And this is truly interdisciplinarity based research, because mechanical engineers can come in, you have computer science people, you have electronics people, and all of us can combine together. And there is a real opportunity for this interdisciplinary research teams to be created across the institution, setting up a small research group in this domain, and then working on these emerging domains and solving some of the challenges that are visible in this particular domain. So it's a very exciting time, it's a very exciting domain. And it's a very very relevant topic that has been selected for today's discussion. I wish the participants all the best. I am sure it will be a great learning experience, and you will leave this symposium with a lot of food for thought for future, work. And just keep the learning going. Be curious and just try and figure out what the real problems, the real challenges are, and what kind of solutions, innovative solutions, can be designed based on that. As far as I am concerned, whenever I look at these problems, all I can see is patents and research ideas. And so it's just about training your mind to look at problems from an opportunity perspective, and then trying to solve it using the tools that we already have in our arsenal. So all the best. Thank you once again to the wonderful organizers for always thinking of me and inviting me for these kind of events. It's always a pleasure to connect. It's always a pleasure to share whatever little I have to share. और बहुत अच्छा लगता है आप सबसे मिलके वर्चुअली, बट जैसे सोनी सर ने कहा, होपफुली नियर फ्यूचर में अगर वहाँ आने का सौभाग्य प्राप्त होगा तो ज़रूर आएंगे. And अच्छा लगेगा वहाँ पे आपसे बात करके। धन्यवाद।
Thank you, sir. Thank you so much for your wonderful session. And sir, we will be honored if you come here, as Soni sir requested to you. Please come here. So we will be glad to hear with you again and again. Thank you,
Thank
sir.
you.
So I would like to thank our Honorable Chief Chairman, Dr. Vijay Badekar sir, and Dr. Narendra Kumar Soni sir, Principal of VPM's Maharshi Parshuram College of Engineering, Bhubaneswar, for always being there with us. Thank you, sir. Uh, so I would like to thank all the participants for joining the this inauguration session and to attend the excellent session and introduction session by Dr. Ankur Gupta sir. Thank you, sir. I also like to thank our organizing partners, Dr. Babasaheb Ambedkar Technological University, Loneri, and STM Journals. I also like to thank our organizing secretary, Rahul Kundia, sir. And with permission of guest speaker and principal, sir, I would like to conclude the inauguration session and will continue with the keynote speaker session.
Thank you, everyone. All the best.
Thank you, sir. Thank you very much, sir. Thank you.
Namaskar, sir. Thank you.
Thank you, sir.
Thank you.
Okay, so good morning. We'll continue with the keynote speaker sessions. So I hope Dr. Srijit sir have joined. So, am I audible?
Yes, ma'am.
Okay. So, with the permission of Srijit sir, Dr. Srijit sir, I will start the session for the next, that is the iSMILE 2005, the International E-Symposium on Smart Infrastructure Manufacturing, AI and ML, Industry 5.0, and the Sustainable Infrastructure Energy for the Future, organized by BPM's Maharshi Parshuram College of Engineering, Bhubaneswar. So I would like to briefly introduce Dr. Shrijit sir, who is currently working as an assistant professor, Rajagiri College of Social Science and Rajagiri Business School, Kochi, with expertise spanning across data analytics, text analytics, and cutting-edge tools such as Python, R, then Power BI, and Orange. His research and teaching contributions have significantly impacted both academia and industry. He has passion for leveraging data to solve real world problems, and his work stands at the intersection of AI, machine learning, and smart data interpretation, all of which are central to the vision of Industry 5.0. It is an honor to have him for the first keynote speaker at iSMILE 2025. So I request sir to start the session.
Thank you so much, ma'am. Am I audible, ma'am?
Yes, sir, you are audible.
Yeah. Okay. Good morning, everyone. Thank you so much for the invite. I'd like to thank the entire management and Rahul sir for the invite. And I'm so honored to be in front of this wonderful audience. In continuation with Ankusa's wonderful presentation, giving an holistic picture of what can you expect from the symposium, I'm just trying to continue the same direction with touching on the point digital twins as he mentioned in his presentations. The topic which I wish to have a short discussion is digital twins as a federated learning platform. But the topic is bit relevant from the research perspective as well as the practical industrial perspectives. So this is the base for today's discussion. I'll try to give some idea of the topic in from a computer science or ML or data analyst or from a business perspective. Basic agenda of the session will be giving an idea of Industry 5.0 context with respect to this presentation. Digital twins in industry, understanding more about digital twin from the industrial perspective, federated learning for the industry perspective, how these two things can be brought together in the sense convergence, and few bit of use cases and what are the challenges and solutions from which we can think the future outlook, what can be the future gap or future perspectives, ended with a question and answer discussion, which I try to manage. Now, beginning the context, Industry 5.0, for the last few decades, mainly the last three industrial revolutions happening with a quicker pace than Industry 1.0 and 2.0. So that 3 to 4 and 4 to 5 is happening in over, fast, moving in a fast pace, and of course, yes, there is a shift in industrial shift. Now, what shift is exactly happening with respect to Industry 5.0 from automation focus to human centric or human machine collaboration for a resistant, sustainable, and ethical industrial practices? So, that is the major shift happening from Industrial 4 to 5, apart from what is automation and electronics things, ML things happening in the current trend. Now, we can have two core enablers other than the things which is already existing, something like digital twins as well as federated learning. Sometimes these things are very popular, known to everyone. I'm just trying to give some insight on these things, how to be connected in a different perspective. So digital twins are actually virtual replicas of physical asset that is fed with real-time data stream, which helps for simulation, diagnostic, and decision making. And when it comes to federated learning, that's actually the concept comes from data science and machine learning context, where this is actually a distributed ML concept, machine learning concept, which can be applied over decentralized data sources for a collaborative AI context by preserving the raw data at the local instance itself. We will talk about these two topics further. These are the basic gist of the concept digital twins and federated learning. Now, the convergence vision, how these things can combine together for some purpose. So in that case, DT can act as an intelligent local agent other than what they are used to. Then AFL, federated learning, can use for a collaborative learning. And combiningly, we can get a secure and proper, full-fledged industrial AI ecosystem. So this is the base gist of the discussion, what we are gonna have today. Uh, More into understanding digital twins in industry, because digital twins are used in various cases, even in business, automation, and many other places. So try to understand how digital twins are used in industry or from the industrial perspective. Um, a definition by IBM, I feel this is more explainable and this is more relevant for this definition for this digital twin. So, as per their definition, a digital twin is commonly defined as a virtual representation of a physical object or system across its life cycle, updated from real-time data and using simulation, machine learning, and reasoning to help decision making. So, final goal is actually reasoning and decision making, and how it was achieved with a virtual representation or replica of physical object or system. And the very point need to be considered is across its life cycle. That's a place where people used to miss the context. So life cycle, it should replicate the entire life cycle of the object, that can be physical or a system or a process, fed with real-time data, that's end in simulation and applying machine learning for decision making. So that's how beautifully IBM has defined digital twin. Coming to the industry, that can be applied over machines, production lines, power grids, buildings, and even entire cities for smart cities by enabling what if scenario, predictive maintenance, and optimization. So let us see some practical examples or real-time examples happening in the industry. Most common point where we can see digital twin is actually in the automobile industry. Almost all the automobile giants actually implements digital twins for various purposes. One such example is BMW's digital twin factory. So that's actually factory digital twin for enhancing the efficiency and to have a sustainable growth continuing, and also supporting the digital transformation goal. So that is one example from a different perspective. Let us see the second example, which is Thames Water System of UK, that try to, so they are working on water supply and water network, water management, and they try to replicate a water network. So that is a kind of process flow or network flow mechanism, digital twin mechanism. They try to optimize their leakages and optimize resources accordingly. Third example can be into GE's renewable energy, to General Electric's renewable energy context. They try to create digital wind farms, which have multiple sub-digital twins of wind turbine, where they try to optimize the wind turbine blades angle as well as the other turbine angle as such to improve the power efficiency or power production efficiency. So these are few examples of digital twins, how it is used in industry in various contexts as such. To get a clarity on these topics, we need to understand what are the different types of digital twins. These are actually defined from different perspective by different sources, but I found this the one which I selected by Jeff Winter, who is actually an Industry 4.0 and digital transformation enthusiast. And this sounds interesting as well as holding the entire portion. So, as per his definition, type of digital twin can be of 5 P's, where start with part, or sometimes it's defined as session or component or part of a mechanical or physical system, which represent how that part, the digital part, can work and further continues. So now second will be moved to product, where it can be a interoperable between these components, or we simply say collection of these parts and components, where it represent together as a product. So if you want to have minute level detail comparing to how it works as a product, then I'll go with product type digital twins. Moving from that, we can have a plant digital twin, which takes the factory or the entire facility or the plant itself as combined as a whole asset. So that's the idea of plant-based one, which is more useful in the operational level context. From that process, so process more commonly try to see the workflow of process of system, or simply say network of system, or say workflow or supply chain management. So there are different contexts which inherits process digital twin context. From that, lastly added is the person, where digital twin that try to mimic a person's behavior, interaction habits, that's in the current trend, which will help them to simulate the behavior of a person with various input, helping healthcare, pharmaceutical, and hospitality sector as such. So these are the various types of digital twins you can think when you have a problem related to digital twin simulation, and going further in that direction. Now, various studies, one very particular, Biller and Biller's 2022 study, they clearly identified or understood and stated uh, these digital twins can be beyond simulation. In the sense, it can be beyond digital replica, but an evolving learning system that continuously synchronize with the real world data or real time data fed into that supports advanced analytics and decision making. So other than simulation, so till these days, digital twins are mostly used for uh, simulation and to an extent predictive analytics, but actually this can be beyond these two things as a holistic learning system that continuously evolved as it is continuously fed with the real-time data from different sensors. Now, what this enables, so it enables real-time synchronization between the physical and virtual nodes with sensor data, predictive visibility, any kinds of nature needing predictiveness, and corrective feedback loop. This is the one which most commonly missed at the this section, where the output of these digital twin should be fed into the digital twin as such as an input, so that it will learn and optimize its process further. And this is how it can be used in general in the industry beyond simulation. Now, as per the Digital Twin Consortium, there are various essential characteristics when we want to define a digital twin. The first can be it should be a physical representation. Of course, yes, that's the purpose of digital twin. Synchronized virtual representation, so that is somewhat achieved nowadays through various real-time data feeding as well as sensors connected throughout. As Ankush rightly mentioned, entire industry or the firm or the company process should be connected to achieve this particular context. Then integration of AI, ML, and simulation. With the help of these data, I can achieve some actionable insights out of it. And finally, which is the things weekly address, closed loop adaptation and learning, where I need to give the corrective feedbacks based on the learning to further optimize the entire process as such. So now, with this understanding why DTs are beyond simulation, what it can enable, and what is the expectation, let us see how this can be coming into industrial capabilities with few examples. Maybe, for example, predicting product quality and equipment failure or the content failure before that occur, which actually supports. So these are actually based on the recent studies happen, and these predictions may support, as the common sense says, support zero defect manufacturing and resource efficiency. And this is the target why these predictions are actually used for. And also self-evolving models, so that is something which we need to add along with the DTs, as this evolves as a model which continuously, because the scenario situations may continuously change in the industry, and this self-evolving models will continuously learn and adapt to the changes happening in real world scenarios. Now, how this can be strategically used? So apart other than industrial capability, one such use case we have seen moving into strategic industrial role. This this in the sense, digital twins can actually bridge between physical and digital world by mirroring the actual real-time assets. So why this is needed, or in how this can be used other than simulation? So this will actually can be a virtual test bed for any experiments or testing that need to be done for some optimization practices before real world deployment. If this is not happening, if I'm trying to deploy the optimization without these test beds, it can have some downtimes which incur in loss, or it may work as unintended things. So virtual test beds will be very useful, where I can see how that changes or optimization process works in the real world scenario without no loss or less minimum loss happening. And other than this, it can help human machine collaboration, which is the major context of Industry 5.0, where human centric human machine collaboration, where based on the dashboards, feedback loop, we can actually enhance the outcome in a consolidated or holistic way. Expert feedback loop improves model accuracy and decision quality. So this is again a least touch area. Expert feedback loops are not still included, mostly into automation, machine learning automation things happening nowadays. Moving to federated learning. We have seen what basically digital twins are, how it can be benefited in industrial perspective, and what I can do with those things. Moving into federated learning, which actually comes from a different perspective of machine learning and data science or security perspective. So it's a mix of cyber security plus machine learning plus data governance. So the context is simply explained as a distributed machine learning framework where clients, that can be anything, devices, organizations, IoT, IIoT, any sensors, it can be any clients, trained on a shared model without sharing the raw data. So that is what basically federated learning concepts is. To make it further simpler, how it works, each client trains locally on its private data set. Only the model updates, in the sense, only weight or gradients are sent to the root server, and a central server or peer network aggregates update. A new global model is shared back to all the client, repeat over multiple iteration. Now let me explain these steps in a very layman understanding. Uh, Assume Google, or instead of Google, we can say mobile network providers. There are VI, Geo, and much more things. They want to actually construct a model, a predictive model, where they want to predict when the humans or when the users will sleep, so that they can further optimize their resources to enhance their energy efficiency by switching down their data centers or minimizing their utilization. So all the industry, all the service provider, mobile service provider, want to create a model where uh, they want to understand when the users used to sleep. Now, what happens? All of our phones have tracking when we use our mobile phone. Is all the data are directly sent to Geo or or the service provider? They have the entire user data. What I'm doing, what kind of things I'm doing, when I see all the sensitive data. Anyway, user data are actually considered sensitive. So they have all the sensitive data, even if they are not misusing it. There is a chance of data leakage or data misusage or security concern happening. So at that case, assume my mobile phone create a model to predict when I will sleep, and only that model parameter, the conditions are sent to the root server or to the Geo. And even from all of you, all of all of the 27, all your mobile phones will sense when you will sleep, and instead of sending the entire time and date and other things, it sends only the gist or the model parameters to the geo server, and they will aggregate all the 27, 28 people's sleep pattern and give a consolidated or aggregated model, and that model will be sent back to all of the 27, so that our phone's model will be more accurate when I'll be sleeping based on different combinations. So this context is actually called as federated learning. Clearly says distributed. How this becomes distributed? Individual mobile phones work as a model to predict when we will sleep, and those data are trained in the local itself, and only those model parameters are shared to the central server. In our example case, it can be Geo or VI or any network provider, and they will construct the aggregate update as a single model and return back to individual mobile phones. So this is one simple example how federated learning works. Now, what are the key benefits? So when we talk about key benefits, majorly or the primarily thing is data privacy preserved, in the sense all the data are raw data is processed at the local source itself. In our example, mobile phones is not taken to the cloud server, so data privacy preserved. Reduced bandwidth if it is something related to human movements. In the case voices or videos are recorded, if all the time these videos should be taken to the root server, a longer bandwidth or the data usage is there. So by just sharing the end model updates, we are able to reduce the unnecessary raw data transfers, reducing the bandwidth. Then, a very important factor, regulatory and IP compliances, as industry is more sensitive towards the data, and various countries, even India, have data information act, various information acts are there. In US we have the HIPAA act, and in Europe we have the various acts as such. So now uh, these data compliances or regulatory compliances are there. FL will help to comply with these IP compliances. And then finally, this will help you have a collective intelligence. Instead of having each mobile phone's pattern, how we sleep, it is taken to the root server and given with like a holistic or collective intelligence to each phones, so that it will be able to predict in a better way. So that's a collective intelligence. So with these understanding, in a simple line, we can say learning from decentralized data while staying secure and compliant. So this is all about how federated learning works in general. Coming to federated learning in industry, how this context will support industry. So most of the cases, industrial data are actually siloed in the sense isolated from department to department, device to devices, because of various reasons such as privacy or even bandwidth limitations. So data is kept isolated. For example, sensor logs, failure data, or industrial supply chain management data, or any such data. All these data are actually kept isolated. We call it as data silos in industry. So with this, there is a limitation of centralized AI, where because of this data volume or sensitive data set, there is a problem having a centralized cloud AI for the entire automation context. Mainly in the case of pharma, aerospace, or even many health related data cases. So now what FL, federated learning, can does is enables decentralized collaborations. So now without sharing the actual models or the raw data, a aggregated model can be built on the centralized server without sharing the actual raw data. Now, this is one of the beauty of federated learning, what it can do in the industry cases. And second one, it actually helps to learn from rare events. For example, I can say there are various turbines, and each turbines may get fail at various points, and this is a rare event. From a single turbine, I'll be able to learn something few. If I'm able to collect data from multiple turbines, how it feels, which is a rare event, I'll be able to have a enhanced learning from all these rare events. Such as in smart cities, we can call disaster management, flood management as such. So even in industries to smart cities, I can use federated learning for these purposes, which bypasses majorly the security concerns of sharing raw data to the root servers. Real world application, uh, one I'm just pointing very few: predictive maintenance in manufacturing, energy and transportation, where it can be applied in smart meters and fleet vehicles, that will enhance updates as well as forecast how much energy and need to be, or the health of these devices can be monitored in a better way. And third one, built for heterogeneous environment. That is something very important in the sense most of the cases industry have in heterogeneous data input as well as context, where FL will help to get insight from all these heterogeneous patterns. It have flexibility. That's what I want to convey. It have its own flexibility, as only the model instance or the parameters are taken, not the actual data. So in that case, it will help IoT scale systems. In the scale, in the sense scalability either by context or by size of the device. And then by design itself, FL is actually privacy preserving. Wherever there is a need for privacy preservation and aggregation, I can use FL in the real world scenarios. Now, why digital twins as a federated learning platform? We have seen digital twins as well as federated learning in separate, almost by discussing all the essence of two contexts. Now everybody will be able to understand how digital twins can be used as a platform for federated learning. So basically, anyway, digital twins are replicas of physical assets, which is fed with real-time data for real-time monitoring and simulation. So beyond simulation, why I can't use this data for prediction? That's also already done. The local ML models. Now, why can't I use these local ML model further to a what is it, global AI context or industrial AI network? So to take that, I'm using federated learning. So local intelligence plus global collaboration. So I can use the digital twin strains model, locally model with real-time data sensors. With this may solve small data problem, in the sense most of the cases each digital twins will have small data, or the data associated with things are actually small. When I combine multiple source intelligence model, then I'll be able to solve the problem of small data collectively, combining all the rare events as such we discussed earlier. Now, third one can be collaborative knowledge sharing, very specifically, as mentioned, federated twinning for multiple twins. So there are multiple twins in the sense it can be parallel or sequential twins. For example, we have seen part, product as well as facility or the plant. In that case, there are multiple twins anyway associated. This will help to have a collective knowledge sharing among them. Privacy preserving industrial AI. So now company actually relies on their proprietary data. So most of the cases industry, based on the industries, they have their own limitation and data governance which need to be considered before sharing the actual data. By this combination, privacy preserving industrial AI will be the result of it. Then self-evolving AI network, as we are able to provide self-learning context or filling the loop context, the network will keep on self-evolving based on self-learning, self-feedback providing with the real-time data. So that becomes a holistic AI network which evolves over time with the various digital twins, local ML models. Uh, Now, how this will enhance industrial AI? What are the area you can touch for research as well as the progression further? Contextual data exchange. So if I use DT, digital twin separate, it will just focus on simulation of the physical asset with real-time data transfer. If I use generic FL mechanisms, then only the sensors data models are actually considered. But if I combine these two things, then there is a chance of understanding the context in the sense semantic, why that sensor is working in the cases, to apply the simulation context. And based on that, I'll be able to understand the contextual data exchange instead of basic prediction, just like interpretation kind of things. Moving beside, we can see physics informed learning, which is another trend which is more into industrial practices, where physics related or physical equations are actually used along with ML models to boost the accuracy, so that for example thermodynamics equation will be used along with the ML models to enhance further to mimic the real world scenarios of the process characteristics. From that efficient communication, now as there is a earlier there was a limitation with respect to sharing raw data resources with two reasons. One might be the security or governance related control, or second may be the bandwidth, the industrial bandwidth, network bandwidth, how those things, how the large data can be transferred. So with this combination, effective communication is possible by sharing the model parameter instead of the raw data, reducing the bandwidth as well as protecting the IP of the industry. Then next one, decentralized digital twins. So digital twins, all we know. So now become the concept of FL, then it becomes decentralized digital twins, where we can actually solve multiple complex non-linear systems by understanding the flexibility as well as the uncertainties happen by learning the rare events as such. The last one can be towards structured collaboration. Now, uh, as we know, digital twins ensures focused, high value knowledge transfer. So that context is actually called as vertical federation. So now among industry, I can use these digital twins for sharing details through FLs. Till this point, we try to understand what are digital twins, how it helps industry, use cases. Then we move to federated learning, which is from cyber security, machine learning perspective, how it works, what it does, or how it can be useful in industry. Now, how we can achieve that in a layman perspective, or what can be the basic architecture behind that as per the latest various research happening. So there are two way. One is the simplest way. There are multiple twins directly connected to the central server, or this is the layered approach, which is most successful and most useful one in the current scenario, which have a edge layer, fog layer, and cloud layer. Edge layer that is placed closely near to the physical entity. This is that will be the actual digital twin replicating the industrial assets or parts or process anything. Then there will be a middle layer called as fog layer. There will be one or more, generally one intermediate layer, which we call as fog layer. So this layer will be the first level of aggregating the updates from multiple twins to reduce the latency and optimizing the bandwidth to the root server. So now root server will have limitation as its middle buffer point. Fog layer acts as an aggregation layer, nothing else that will do, so that the resources or the model aggregation will happen in a smooth manner, and those aggregated things will be moved to the root aggregator, which is called as the cloud layer. So cloud layer will be the high level model aggregator across facility for global model refinement. So this is how these things work. To explain the same thing, if I take the example of that mobile phone sleeping pattern, uh, at the tower level, it will have digital twins of our mobile phones that will work as an edge layer, and that edge layer will have the digital twins of our mobile phone, try to replicate everything, and from there it was taken to the central hub root server where it acts as a fog layer, and then aggregated data will be further taken to the root core or root or core central server of any information provider. So that's how the layered approach can help you to minimize the latency or information latency or the process latency. latency, optimizing the bandwidth. Use cases are already discussed earlier. Still, to give one or two: smart manufacturing, supply chain optimization, which comes with the process flow that supports the uh, process digital twin, energy and IoT systems, where it saves the privacy with the help of blockchain assisted. So there are various security mechanisms that need to be used if there is some way of security related. We'll talk about all those things in the next slide. Then smart cities and healthcare, that is one area which is continuously evolving. For example, smart city with respect to disaster management and smart water network management. So there are various advancements happening in that particular area, and also in the healthcare, pharmaceutical, and healthcare with respect to people digital twin as well as process. Combining these two things, how the dosage simulation can happen. So these are the few real world scenario where, apart from industry, these combination will be very helpful. Coming to the point, challenges and solution, which opens the door for further researchers as well as the touch points. Initially, as these are dealing with data, of course, yes, security and privacy. That will becomes one challenge. And most common attacks or threats coming into the picture of federated learning is model inversion as well as model poisoning. In the sense, model inversion in the sense, uh, somebody will try to get the raw data or raw data patterns from the model inputs. So when the model insights or parameters are transferred, some attackers will get into the network, try to inverse the model and get the patterns of actual data. So that is what we call as model inversion. Then something called as model poisoning. So poisoning in the sense, if I'm not able to get the actual pattern, then I can do some data injection, or I can shuffle something in between, which will create the bias or will transfer the wrong model parameters to the central server. So this is the common threat which comes under federated learning. So these things can be actually uh, addressed by various solutions such as blockchain, which gives the context of authenticity, in the sense who and who tamper proof resistant. If somebody changes something, they'll be able to know what and how it was, not who, how and what changes are happening. Then through secure multi-party computation as well as differential privacy. So these are various solutions which addresses the threats related to model inversion or poisoning. Then into another one is actually interoperability and standards. So now, as we know, digital twins can be multiple twins, multi-level twins, or consolidation of multiple twins. Then there is a need for interoperability so that multiple digital twins can communicate in an easy way. So for that, there should have some kind of standards. There are one standard. It's not actually standard. DTDL in the sense, uh, digital twin defining language by Microsoft. That's a language used to construct digital twins. So I can follow that standardization so that if everyone uses the same standardization, then we can actually connect two digital twins, or the interconnection between the digital twins will be possible. Or I can use digital twin consortium. As we have seen earlier, there are multiple guidelines given by the consortium, what should be the factors that need to be considered as its basic practice. Then third challenge is energy and resource constraint. As Ankush already mentioned, in the real world scenario, energy constraints and use cases, resource constraints are actually a real world problem. And with the architecture, layered architecture, as we have discussed, edge fog cloud, we can actually improve this by creating lightweight models. So now there will be having multiple layer with different purposes. I don't want to share the entire data, but still at each layer there will be some processing happening, and uh, only the aggregation will happen at the root node. So with this lightweight architecture, I can achieve energy efficiency and resource constraint problems neglected. And next one is actually the governance and trust. So now moving into a greater collaboration. For example, if BMW as well as Audi or any other Indian automobile industry want to collectively construct one AI model by providing inputs, then how this can be attained? Nobody wants to share their own perpetual data, right? So in that case, I'll be using the context of the DT and FL, and for this, there should have a proper incentivization, smart contract, as well as fair contribution mechanism. That's actually something governance context, not actually into the system context. So there should be a proper governance regulation to enhance the trust as well as collaboration between various entities. So this is from a different perspective. The last one can be model drift and validation from ML perspective, in the sense machine learning perspective. Model drift uh, is actually or also called as concept drift. So there are two drift in ML. One is data drift as well as concept drift. So data drift is something like mm, earlier, for example, there is some genetic changes happening. So with that, in the previous times, the size of the chicken or a height of the humans are predicted based on some characteristics. And later, due to the time changes or some other changes, now the human height got varied. And if I still use the same model to predict that anyway, it will not work better, because the data distribution got changed from 4 to 5 feet to 5 to 6 feet. So that is what we call as data shift or data drift. Moving into concept drift or model drift, I can say an example of motor. For example, I have trained a model to predict whether the motor will get failed or not based on the vibration. And later, I have changed some parameter, for example, rubber bush or something in the motor, and now not anymore that motor will produce the same set of vibration, and I can use that model to predict the failure. So now it's not about the data, it's actually the concept. The entire model becomes invalid because of the change in context happening. So that is what we call as model drift or concept drift. So model drift and validation is one problem in digital twin, where uh, in before deploying in the real world physical network, I can actually use digital twin to simulate the test modules before deployment in a over a periodic time. So from different perspective, security and privacy from cyber security perspective, interoperability and standard from the industrial standard perspective, energy and resource from the energy consumption perspective, governance and trust from governance perspective, model drift and validation from the ML and data science perspective. So these are the few area of challenges where you can touch or consider for your research to fill the gap, and how it can be taken further into account. Now to the future directions. What are the future directions? Federation 5, in the sense human in the loop. At the beginning, we discussed actually there is something missing, as the industry 5.0 says, human centric or human machine collaboration, where human in the loop system will enhance the expert knowledge or the knowledge in the systems via digital twins. So human in the loop is actually required to enhance the knowledge. Second one will be digital twin as a service. So that is something from a business perspective, industrial business perspective. Digital twin as service, DTAS. So normally from the computer science perspective, there are business done with the help of various IT resources. For example, software as service. You are more familiar in the sense you can view Word document, PDF online if you have Cloud 365 or something like that. So that's what we call the software as service. So you need to pay for monthly for that particular service. You don't own it. You need to pay in the base of how you use. Then our cloud data, in the sense drives are actually storage as service. So we used to pay, if we need more than 5 GB, we will pay for GB. So we don't own that space, but we get that space as a service. So why can't this twin as a service be a service, and with that the industry can have something like plug and play kind of thing. I don't want to create from the scratch. I can just get the service, deploy, connect with my industry, and go further with that. So it's a win-win situation for the industry as well as the service provider. Then self-optimizing digital twins. Self-optimizing digital twins, AI enhanced, physics informed, and explainable twins. So all other things are already covered. Explainable twins. So there is one trend happening in data science or machine learning, which called as XAI or explainable AI. So most of the machine learning or deep learning methods are kind of a black box, in the sense we provide the input, system will predict whether it will fail or not, it will succeed or not, what can be the forecasting. So anyway, I'll not be able to understand why that prediction comes. So that's what we call as black box. So to explain that black box, there is a concept called as explainable AI. It will try to give an idea why that, because of what parameter that decision was made. For example, if the system predicts or digital twin predicts there will be a failure, and I want to know because of what case that machine will get failed. If that can happen, it will be more useful for human. As a human in the loop, I'll be able to understand more and provide useful inputs to the system to fine tune further. Right. So this is what we call as explainable AI, and the context of explainable twins comes into the picture. Then the last one, Internet of Federated Digital Twins, IOFDT. In the sense, we have already Internet of Things or Industrial Internet of Things, something called as Internet of Federated Digital Twins. So this will help to have an twin ecosystem, by combining all these digital twins, just like how the current sensor network works as an IoT. It tried to collect all the local models or intelligence to have a collective intelligence for a sustainable and resilient industrial practices. Right. So in this way, we'll be able to use uh, digital twin as a federated learning platform through which we'll be able to achieve human in the loop as well as uh, sustainable industry practices to gain a global generic AI network, industrial AI network. That's what I want to convey. If I want to summarize simple, we discussed about digital twins, we discussed about federated learning, how both will be useful in industry, how both can be combined together, and what is the basic architecture way to touch it, and what is the gap area, and how to fill it, what can be the future. So these are the gist area where, as I'm not a person from the mechanical or industrial engineering person, you can fill those gaps from with your own knowledge area as well as your area fillers. Thank you so much. That's all from my side for the today. Thank you for listening.
Hello. Am I audible, sir?
Yes, ma'am. Yes.
Okay, so dear participants, I request if you have any questions related to digital twins as a federated learning platform, you can communicate with sir. We have 10 minutes. Please communicate with sir if you have any queries or any questions. Sir has shared already his contact details. If sir has given permission, then you can contact him with proper permissions. Uh, yes, sir. Is it okay?
Yeah, sure, sure. More, my pleasure.
Okay, sir. Thank you. So, any questions from your side, or we can continue with the session? Anyone is having any question, you can communicate, or you have contact details of sir displayed on the screen. So you can contact him in future if you have any queries related to the topic or any other queries with his permission. So, sir, thank you so much for the wonderful session. Actually, the session was really helpful. We are not very well known about the digital twins, but after your session, we are we have got so much information about the digital twins as a federated learning platform. You explained the digital twins beyond simulations as well. Also about the federated learning, you explain how it works, what are the benefits, what are the real world applications of these federated learning as well. Then you also explained about the digital twins and federated learning architecture as well. What are the challenges which we are facing in this field, and what are the solutions for the federated learning and the digital twins platform? You also explained that. Thank you so much for that. Also, you explained about the given future directions and towards the industry and society, which will be helpful for the all the participants. So, thank you so much, sir, for your wonderful session.
Thank you so much.
And
I know
thank
I
you for
rushed a bit, but I just want to cover as much as possible to give the baseline. I know a bit, it was a bit rushed and a speedy presentation. I know it, but I just want to deliver as much as possible. Sorry for that.
no, sir. Actually, you delivered very informative session. So this platform, I think we are not. I'm from the civil engineering background, so I'm not aware about this in detail. But after your session, I think all the participants got very much nice information about the session and about the digital twins, federated learning as well.
Thank you so
So
much.
thank you for the session, sir. And as the participants, if they have any questions, they will ask you or they will communicate with you.
My pleasure. I'll
Okay.
do it.
Thank you, sir. Thank you for joining the session.
Thank you so much. Thank you everyone for listening to me.
Dear participants, we have another session by Mr. Premanand Narsimha, sir. So we will wait for the speaker will join soon. So please wait for some time. I request all the participants to wait for some time. Our next speaker, Mr. Premanand Narasimha sir, is busy with his schedule, so he'll join within 5 minutes. Please wait. Hello. Uh, Narasimha sir, am I audible? Sir has joined.
Good morning.
Good morning, sir. So, if you permit, sir, can we continue the session?
Yes.
Okay, sir. So, dear participants, it gives an immense pleasure to welcome you all once again to the International E-Symposium on Smart Infrastructure, AI and ML, Industry 5.0, and Sustainable Infrastructure and Energy for the Future. Hosted by VPM's Maharshi Parshuram College of Engineering, Varneshwar. I, Ms. Bhakti Ghorpade, welcome you all for the session. We are truly honored to introduce our today's distinguished speaker, Mr. Premanand Narasimha sir, a globally respected expert in information technology, cybersecurity, artificial intelligence, and entrepreneurship. Mr. Premanand Narasimha sir is a fellow engineer and certified independent director and director of TechSpark OPC Private Limited and Pragya AI Private Limited, where his work is focused on pioneering next generation technology solutions with an outstanding 35 years of experience in IT, engineering management, training consultancy, and research. His contributions span across cybersecurity, AI, telemedicine, and quantum computing. He is also the Honorary Vice President of Cybersecurity of India and a technical advisory of Typhon Pharmaceuticals and Apollo Telemedicine. To name a few of his many affiliate roles, a passionate educator, Mr. Narsiva is a visiting and regular faculty member at top institutions such as VIT Vellore, Beltech University, Jain University, and National Academy of Customs, Indirect Taxes, and Narcotics. With numerous national and international lectures under his belt, from Doordarshan debates on cybersecurity threats to guest lectures on quantum computing, constraint management and entrepreneurship, he has been consistent force in shaping digital and technological discourse in both academia and industrial ecosystem. So now, with great pride and anticipation, I invite Mr. Premanand Narasimha sir to deliver his plenary talk and share his insights with us. The screen is all yours.
Thank you for your kind introduction. Uh, I would like to start today's lecture with a brief introduction of Industry 5.0. Okay. Now, Industry 5.0 will bring all great minds literally think alike. Okay. A clear example of our revolution is the latest introduction of ChatGPT, which is a OpenAI tool. Until now, AI models excelled in gathering data, identifying patterns, and then pinpointing some root causes. Today, we have a tool which literally replaces many human beings. Yet, it will not worry everyone to think that they will lose their jobs, but it will enable them to work in a much better fashion. Let us have a recap of the industry revolutions, which are four in numbers. Let us recapture them. We had the mechanization starting in the 1780, the first industrial revolution occurring over about 100 years from the mid 18th century, and it began to automate several processes which are unimaginable. Then came the electrification in the 1870s, and we had the electric power factories and assembly and production. Finally, we had the automation in the 1970 with digital technologies including robotics came to the manufacturing process. And finally now in 2011, along us, we have cars, computers, robots, toasters, everything becoming intelligent. We have internet enabled devices all over the place. Minimal intervention and factories that work in their own way by bringing in cyber physical systems is the order of the day. Okay, now let us see what is Industry 5.0 is doing. The fifth industrial revolution is seeing the beginning of convergence of machines as well as human beings. We have smartphones and applications that are giving way to technology to enable us to work in a much better way. Industry 4 5.0 is about transforming Industry 4.0, which is cyber physical manufacturing of plants. So if you have your supply chain enabled with latest technology, say we have just-in-time manufacturing in many industries we have seen. So what happens is the IoT or industrial IoT devices, they capture the inventory in your shelf and then intelligently looks at what is the minimum order quantity that is required for production and then process the purchase orders and send them to the suppliers. Now, this gives an ability for us to think and do just-in-time manufacturing without much of human intervention. So the inventory is being checked. What is required for manufacturing for the next 4 weeks is ascertained, and the order is placed with the supplier. Once the supplier sends the goods, it is received and automatically quality checked and sent to the inventory. So this is absolute automation of supply chain to some extent, and we have computers with large memory capacities that make us work in a totally different manner. You see, the Industry 5.0, it relies on data, devices, and generative AI. None of these components works without memory. It doesn't work without computers. So everything we do happens as a result of sensory input. Okay, so we have various sensors that have with our devices. So instead of CPUs performing to process data, most artificial intelligence systems use graphic processing units, a different kind of computing chip that needs a different kind of memory to maximize performance. While a CPU may have 8, 16, or 32 processing cores on a chip or chipset, GPUs may have thousands. So what does it mean? This let them process thousands of data inputs at once, which is what the hungry artificial intelligence workloads require. So companies like Micron are coming out with different memory called high bandwidth memory. These are fast, power efficient memory. It feeds these hungry GPUs with a lot of cores with enough data to satisfy and do powerful cognitive computing. So the various chips that come with high workloads makes us perform tasks that are 100 times faster than what we are doing right now. So there are many uh, applications um, of this kind of computing. Okay, now when we talk about artificial intelligence, we also talk about machine learning and deep learning. So machine learning helps us perform jobs better. There are about 16 applications which have been listed in manufacturing where machine learning is used. Okay, predictive maintenance is one. Then we have quality control, I told you now, and supply chain optimization, which just we discussed that. Manufacturing process optimization, energy consumption in forecasting, energy consumption reduction, product design development. Then next comes market trend analysis and product innovation. Then we have customized and personalized manufacturing, where customers can order cars to their liking with a lot of features that are being chosen by themselves through an interactive computing device. Worker safety and ergonomics, robotics and automation. We are seeing that everywhere. Robotic arms, automated storage, retrieval systems, autonomous guided vehicles, drones. So AI/ML is helping to reduce this limitation as it advances the field of robotics to the next level of automation. Okay, anomaly detection. Finally, warehouse management, and two other important things like supply chain management. Here, manufacturing personnel can use generative AI to help with data entry, tracking of operational tasks, and routing, working with supply chain management software suites, the suppliers, connected suppliers, and generative AI can create procurement orders and request letters directly on software dashboards. So this reduces a lot of time. Then finally, we also see demand forecasting. So manufacturers uh, can do sales and look at sales data and plan to execute production and supply chain operations with the use of just in time. Consumer demand volatility is particularly high, which can create costly problems for manufacturing. Okay, so this is overcome. This constraint is exactly overcome by demand forecasting. And finally, we have automation. So AI ML tools are used to recommend the best action to do automation. Barcode scanners, weight sensors, radio frequency identification tags in warehouses can automatically trigger replenishment when supplies diminish. Few minutes ago, I mentioned that about your inventory. An automaker's robots can detect and adjust for surface flaws while painting cars in production. At the other end of the supply chain, customers will automatically obtain and pay for goods. This example includes the use of IoT devices placing orders independently without human intervention, and intelligent replenishment algorithms are used for this. Okay, next let us look at um, some more on AI and ML. Okay, so let us start the discussion with how we are looking at the artificial intelligence tools. We can start the discussion by saying artificial intelligence and machine learning are together in industries. While they perform certain tasks, they help in revolutionizing operations of the factories. Um, we can call it the powering the future, because today we stand at the cusp of a new industrial revolution, which is driven not by steam, oil, or electricity, like before, but by artificial intelligence and machine learning, which are virtually invisible tools. These technologies are not confined to research labs today anymore. What are they becoming? They are transforming industries, they are reshaping economies, and they are redefining the possibilities across the globe. So let us explore how artificial intelligence and machine learning are becoming the silent architects of an intelligent, predictive, and optimized industrial future. Okay, we have AI driven decision making in industries today. Traditionally, decision making industries was based on experience of the human being, intuition, and the reactive strategies that were practiced. Today, we have AI driven decision making, which brings in real time intelligence to every layer of the organization, unlike it was confined to an individual. So, we have a case study um, from Siemens, where it's called Amberg Electronics Plant. Here, AI models now autonomously make real-time production decisions. They adjust thousands of variables simultaneously and give an optimized output. What is the result? A manufacturing accuracy which has a rate of 99.99% with a downtime reduced over by 30 to 35%. What is the key takeaway here? AI doesn't replace human decision makers, but it empowers them to make faster, better, and more strategic decisions. Using AI algorithms to assist or automate complex decision making tasks traditionally made by humans easier. Okay, so we have manufacturing. You can do dynamic scheduling of production lines, logistics in real-time optimization of supply chains, and if you take the energy, grid load balancing and smart resource allocation can be done. What are the benefits? The benefits are speed and accuracy in our decisions, reduced human error, and better resource utilization and cost savings without human intervention. Here also we have a Siemens using an AI for real-time factory floor decision optimization, including allocation of resources, both human and machines. Industry 5.0 also introduced the concept of using artificial intelligence and machine learning in doing predictive maintenance. Just imagine fixing a jet engine or a manufacturing robot before it fails, not after the disaster happens. So, this is predictive maintenance, which is powered by AI, ML, and transforms maintenance from a reactive cost center to a proactive strategic advantage center. Okay. Machine learning algorithms helps us to predict equipment failures before they happen. How we can do a activity of creating a digital twin and running the manufacturing process before we actually do. So monitoring vibration, temperature, acoustic signals from machines, analyzing with sensor data to predict wear and tear. So General Electric uses their AI platform called Predix. GE monitors critical industrial assets from power plants to aircraft engines. Through predictive analytics, they have saved over $1.5 billion and avoided downtime across their factories. The key message here is maintenance is no longer about repairing when it is broken, but it is about predicting and preventing failure before it happens. Leveraging machine learning algorithms helps us to do this. So, what are the benefits? The benefits are reduction of unexpected downtimes, extended equipment lifespan, and saving maintenance costs. So, we have seen that Predix, a tool, is used by General Electric for performing maintenance predictive maintenance in jet engines and turbines. When deep learning becomes an integral part of the industry, what happens? Machines will learn to see, to hear, and to think like humans. Very interesting, isn't it? We have a case study from Bosch industry, which uses deep convolutional neural networks called CNNs to perform automated optical inspections. Imagine doing a quality check. So here, deep convolutional neural networks called CNNs helps us to perform automated optical inspections on electronic circuit boards. Very, very interesting. The circuit boards, while in production, can cause failure due to some malfunctioning of the equipment or the components. With deep learning, what we can do is we can detect defects and accuracy can be increased by 25%, and manual inspection time can be reduced by 50%. So this is achieved by what? By automated optical inspections, AOI. The benefits are we will have a very, very high accuracy and absolute adaptability to the environment. Most importantly, it will have the ability to process massive data sets by using GPUs. Bosch uses deep learning for automated optical inspections, where especially in electronics manufacturing. So you can monitor vibration, temperature, acoustic signals from machine learning algorithms and do sensor analysis and product uh, warranty. This will help us in faster information retrieval, better human machine collaboration. So we have an example of Honeywell Forge where the industry uses natural language processing to help technicians to quickly troubleshoot problems through what? Voice queries, which are very, very natural. So this case study uses deep convolutional networks and perform optical inspections as well as use voice signals to do a analysis. So how do we do apply AI to understand and generate human language within industrial settings, natural industrial settings? So the applications are AI powered assistants will be there for engineers. They can do automated reporting. They can do monitoring and do alerts. So there will also be smart documentation and maintenance guide with minimal human intervention. The technician can analyze, prepare notes, and help in predicting recurring industrial problems. So by this we have an efficient way that has always been the holy grail of manufacturing. So machine learning will now take the optimization of industries to the next level where human alone cannot achieve the perfection that is being shown by the AI tools. Toyota now uses machine learning algorithms to dynamically adjust its production lines, that too in real time, where they are having the just-in-time manufacturing. As a result, they have seen a 15% reduction in cycle times and a 10% improvement in quality control, even across very, very complex supply chain which exists across the globe in their factories. Using machine learning models to continuously improve manufacturing workflows, we can achieve many better results. One is process parameter optimization, pressure, temperature, speed. dynamic adjustment of production based on demand and forecasting. Here we also use the AI tools to do a resource optimization and also resource allocation, including both machines and humans. By this, we will have maximized yield with a minimum waste and enhanced flexibility while doing the manufacturing process. Toyota uses machine learning to optimize not only assembly line but to also provide better product quality through faster output. Artificial intelligence and natural language processing are very important aspects of Industry 5.0. What is important here? Industry 5.0 is all about communications. Communication is the heart of Industry 5.0. So AI powered natural language processing now enables machine to understand complex industrial languages, technical manuals, and unstructured maintenance notes. These are prepared earlier by both human and machine learning tools. So, a case study, interestingly, with Honeywell Forge reveals that industrial AI performs better while using NLP to do and interpret technical reports. There are technician prepared reports, and this will predict operational anomalies. Because of the experience of the technician, certain aspects of his knowledge goes into these reports. Now, this allows the engineers to speak or type queries naturally and get AI driven solutions instantly. Imagine in a factory where you have sheet metal cutting process. You need to do the cutting of the sheet metal to produce a car's body or door or whatever, or in a lift manufacturing unit where the body is you know made using sheet metal. It requires some algorithms, some formula to arrive at a position where you will have minimal wastage of the sheets. So this is done by various algorithms, various experience that have been gathered in previous production lines, and that can be typed and kept as even unstructured notes by the technician. And this tool will allow engineers to just speak through a mic and guess the best possible solution to cut the sheet metal instantly. So natural language processing bridges the gap between human expertise and machine intelligence. So here again, we insist the point that AI is not taking away jobs. It is using the human intelligence to store and then dissipate the ability of a person or a machine to do a manufacturing process across multiple factories across the globe by having a single structured or unstructured node. So it bridges the gap between human expertise and machine intelligence, but does not take away the job from humans as such. Now, finally, we arrive at a conclusion by saying artificial intelligence and machine learning are not just futuristic ideas, they are practical, impactful tools which are reshaping industries today by improving decision making, enhancing maintenance strategies, most importantly, enabling precision, precision, precision through deep learning and making the machines understand human language, which is machine learning, and fine tuning every part of the manufacturing, starting from supply chain to sales, to manufacturing, to accounting and management information decisions. So excellence in manufacturing. 5.0 industry is all about excellence in manufacturing, and it is no longer about working very very hard but working very very smartly. It's about working smarter. How we can work smarter? We can have guidance by machine intelligence as well as human intelligence. So when we look at the future, AI, machine learning and deep learning will become the DNA of industrial operations. They will predict, they will optimize, they will also customize and automate. For all this, artificial intelligence will be the tool. It will have a vision, it will have a creativity, and the leadership will remain ours. Human retains the leadership to do things creatively, to have a better vision. But of course, you also have the automated inspections, which helps us to do things in a manner which is today possible but was unimaginable some 15 years back. Let us now go and just embrace artificial intelligence and machine learning and not think them as competitors for our jobs, but as collaborators and partners. They will help us build a future where industry will be absolutely intelligent, sustainable, resilient, and will become limitless. You can do many things with minimal tools. So when we look at the future, it is very, very interesting and promising. We have some quotes from Alan Kay. The industrial renaissance, AI and ML powering the future, is the best way to predict the future is to invent it. So let us use our human creativity to better power the AI tools and machine learning algorithms. Another quote for AI driven decision making in industries: without data, you are just another person without an opinion. This was by Edward Deming. Samuel Johnson says, language is the dress of thought. And we have again another quote by Benjamin Franklin: an ounce of prevention is worth a pound of cure. Okay, very, very important. So, predictive maintenance using AI and ML just reminds us of this: an ounce of prevention is worth a pound of cure. So, machines that learn are the engines of the next industrial revolution. So, we called engines in the previous era what we will now call as the industrial revolution 5.0. So we have machines that are intelligence, that have intelligence, that can learn and predict the future. There is another interesting quote from Peter Drucker, a great man: efficiency is doing better what is already being done. Okay. So what is efficiency? We manufacture 50 cars in a week today. We will manufacture 200 cars or 500 cars in a week by using artificial intelligence and machine learning, or automating the order of purchases, automating the order of uh, production line, automating the process of resource allocation, automating the process of quality control by doing automated optical inspection, automating the process of final quality checking and storing, automating the process of logistics planning and sending the product, and also using AI and ML at the retail end to predict what is required for next week and getting the orders processed and the goods in time to the shop. So this is efficiency in doing better what is already being done. To close, we have technology is best when it brings people together. Matt Mullenweg. So the new industrial DNA is technology is best when it brings people together. Okay, so we have industry, people are working. They think that AI and ML will, you know, grab their jobs and they will be useless. No, this technology has to become a tool to bring people together. How? Create awareness. Okay, do skilling up of your employees, bring them together, understand how to use these tools better, and use their brains to do a much better job and produce goods faster and in a large quantity. Thank you. So I would like to continue uh, answering if you have any questions on this how industrial 5.0 is revolutionizing our times and how it is bringing people together, how it is improving manufacturing, and how the future will be when we have cyber physical components.
Okay, so I request all the participants. Sir has opened the platform for question and answers. So if you have any questions, you can communicate with Sir.
I would also like to cite an example of how um, the AI is being used uh, by using a concept called computer vision in banking. So what one company has done is use the AI tools to process checks that are being manually processed today. So what you have is you have hundreds of check leaves that can be seen by the computer through a computer eye or a camera, and then it can see, it can validate the signature, it can validate the amount, it can validate the amount written in words and the bank, and then processes check. So this increases the processing of checks by 100 times than the manual process.
Okay, dear participants, if you have any questions, you can mention it in chat box, or you can unmute yourself and you can ask any questions if you have. Okay, sir. Considering the time limit, we will forward the questions from the participants to you. It will be honored to communicate with you in the future.
Definitely, I would like to answer any questions that are there. You can send me an email. I will answer those questions immediately.
Okay, sir, definitely. So thank you, sir, for giving us all the informations about the machine learning uses in manufacturing. Also, you have given so many real life examples which will be helpful for the participants. So you have also given the brief idea about the automation. What are the different benefits in the of automation, AI and ML in the real life problems. So you have also explained about the artificial intelligence and machine learning in detail. Also all the benefits about the 5.0 industry 5.0. So thank you so much, sir, for your giving us for your valuable time and the wonderful session. So with your permission, we will conclude this session.
Okay. I hope the session was very informative. If you
Yes,
have
yes, it's very informative, sir.
Okay. If you have any questions, I would like to answer through the email. Thank you.
Yes,
Thank
sir.
you for the offer.
Definitely forward.
Thank you, ma'am, Mr. Rahul and Mr. Gaganan for the opportunity. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Okay, so our next keynote speaker, Dr. Deepika Kaundal ma'am has joined. Ma'am, am I audible?
Yeah, ma'am, you're audible.
Okay, thank you, ma'am, for confirmation. So, following are the insightful plenary sessions. So, it is my distinct honor to introduce our keynote speaker, Dr. Deepika Kaundal, ma'am, a highly accomplished academia and inspiring researcher and a leading expert in the field of artificial intelligence, computer vision, deep learning, and image processing. So, Dr. Kaundal, ma'am, journey as the academic and research ecosystem spans over 14 years, marked by remarkable achievements and global recognition. She holds BTech, MTech, and PhD in computer science and engineering. Her expertise are reflected in the numerous fields she has earned. Among her many honors, she is a proud recipient of Marie Curie Actions MSCA Seal of Excellence, awarded by the European Commission, a testament to the impact and quality of her research proposals at an international level. Notably, she is also been listed among the top 2% researchers globally in both 2023 and 2024 by Stanford University, an achievement that sparks volumes about her scholarly contributions. Currently, Dr. Kandul ma'am serves as a senior researcher at the University of Eastern Finland and holds an interesting positions of Ho Chi Minh City Open University, Vietnam. She is actively guiding six PhD scholars, and her mentoring continues to shape future innovators in AI and computer vision. Her contributions include multiple patents, edited books, and high impact publications in leading scientific journals. Her research is specially focused on the applications of deep learning in medical imaging, an area of immense value to healthcare and diagnostics. She has also received Research Excellence Awards from the institutions like UPS and Chitra University, and her global collaborations further highlighting her commitment to advancing technology for the societal good. With great expect and anticipation, I now invite Dr. Deepika Kaundal ma'am to deliver her keynote address and share her expertise to the our iSMILE 2025, the e-symposium, international symposium on smart infrastructure, AI and ML, organized by VPM's Maharshi Parshuram College of Engineering, Bhubaneswar. Welcome, ma'am.
Thank you, ma'am. Thank you so much giving me this opportunity to share my views on this exciting topic. Let me share my presentation. I believe my presentation is visible.
Yes, ma'am, it is visible.
Okay, thank you for confirmation. Okay, good morning, everyone. I want to start with a question. When you imagine a factory in 2035, what do you see? More robots than people? Maybe self-healing machines? Today we are going to explore that future, a future powered by generative AI and computer vision. I'm Dr. Deepika from University of Eastern Finland, and together we will uncover how these technologies are redefining automation and sustainability across the globe. So before we dive deep, let me quickly introduce myself, but ma'am has already introduced me in a very well way. So my journey began with the fascination, can computers learn to see and think like we do? So from my PhD in medical imaging to collaborations across India, Vietnam, Australia, USA, and now with Finland, I have been fortunate to explore that question firsthand. So how many of you here have worked with AI or computer vision in your field? So, or maybe you have been curious to start. So today's lecture will be going to be more excited. So these are my key achievements, which ma'am has already discussed. So I'm just skipping these. The books which I have written with computer vision and image processing in various domains. So this is not just for the technical thrill. What drives me is a bigger mission. Can these technologies help us solve real world problems like waste, energy, and climate change? So that is the heart of today's talk. So AI not just a tool, but as a force for sustainable impact. So what's the biggest game changer in industry over the last 20 years? So we have gone from manual work to automation, but now we are entering a new chapter, autonomous ecosystems. Think factories that fix themselves, cities that design their own traffic flow, farms that know when to water without being told. So what's one area in your own field that you think is ripe for full autonomy? It could be healthcare, transportation, energy. So let's revisit generative AI here. So it doesn't just recognize the patterns, it creates new possibilities from them. So what is the difference between discriminative AI and generative AI? So discriminative AI asks, is this a cat or a dog? Whereas generative AI says, let me draw you a new animal altogether based on what I have learned. So, would you trust a piece of content, image, video, or article created by AI? So, this is a glimpse of a comparison between generative AI and discriminative AI, where you can see that the applications of generative AI is like image generation, text generation, anomaly detection, data augmentation, whereas in discriminative AI, we are using spam detection, image recognition, sentimental analysis, and fraud detection. So you can see here in this slide that objectives of generative AI and objective discriminative AI is different. Whereas generative AI models the joint probability, whereas discriminative models the conditional probability. So here you can see the major difference between generative AI and discriminative AI. So today my focus will be on more towards generative AI rather than on discriminative AI. So let's open the toolbox making the shift possible. So generative AI, which I just told you, is our creative engine, whereas computer vision is the machine's eye, and reinforcement learning is the learning by doing, and whereas Edge AI and IoT is the intelligence at the device level. So anyone here already working with two or more of these? So if you don't worry, we will decode the magic altogether here today. So this is foundations of generative AI, which is like generative AI relies on advanced machine learning techniques that allow models to create new data rather than just analyze or classifying the existing data, as I already told you. So here we are focusing on three prominent generative models used in image processing and computer vision, which are GANs, that is your generative adversarial networks, VAEs, that is variational autoencoders, and the third one is diffusion models. So what is this GAN? So GAN is developed by Ian Goodfellow in 2014. GANs works using two neural networks, generator which tries to create realistic images, whereas the discriminator evaluates the images and provide the feedback. So over the time, generator improves and produces realistic images like we are used in AI generated faces, deepfakes, and more. Whereas VAEs, that is variational autoencoders, it learns to compress and reconstruct images, making them useful for structured image generation and style transfer. They are often used in medical imaging, anomaly detection, and image denoising. Whereas diffusion models, these models start with random noise and progressively refine it to create high quality images. So it is used in state of art AI tools like Dell E and stable diffusion for text to image generation. So why generative AI matters? It's a very important question because AI generates creative applications like we know today's scenario that what we are using the generative AI, whether it's a chat GPT or Gilby or whatever it is. So we are using image enhancement. We can use image enhancement for this generative AI matters. Generative AI is used in industries like healthcare, where we are using medical diagnosis, in security, where we are using generative AI for deepfake detection, and for entertainment and gaming. So now that we understand how these models work, and let's explore their real world applications in image processing and computer vision in terms of automation and sustainability. So this I have already discussed. So here we can see that ever seen an AI generated face that looked completely real, that GANs in action? So here what actually there are two networks, generator and discriminator. One tries to create the fake data and the other tries to catch it. And they both get better through the challenge. Anyone know a real world case of GAN? We have many examples. So this is visualization of generator and discriminator. There is a fun analogy. Imagine a student forging signature using the generator and a teacher trying to catch the fake, which is a discriminator. So the better the student gets, the sharper the teacher becomes. So unlike the fakes are nearly indistinguishable. So this game is called adversarial training and it's the engine behind high quality image generation. So this slide gives us the skeleton of these two networks with different loss functions and often a lot of patience because training GANs isn't easy. Ever heard of mod collapse? It's when the model keeps generating the same output over and over. It's like a student learning one trick and repeating it forever. Anyone here face this challenge in training the models? So to sum up the core insights, as I told you that GAN works as an adversarial training, which is somewhat like a mini-max game where the generator and discriminator competes. We have discussed about loss functions, like generator aims to maximize the discriminator classification error, whereas discriminator aims to minimize the classification error. GAN evolved through constant challenge. As I told you, mod collapse, where generator produces limited variety of outputs. And the training instability is also one of the challenge where difficulties in maintaining balance between generator and discriminator improvements, we struggle a lot. So their performance hinges on delicate loss functions. But now we have better versions like conditional GANs and persistent GANs to make training more stable. Conditional GANs incorporate labels to generate class-specific data, whereas WGAN stabilize training with a new loss function. So if you are into a research or application, these upgrades are definitely worth exploring for you. Okay, so which use cases excite you most? Healthcare, security, or creative arts? So it depends upon your area of interest. So here are just a few areas where GAN shines. Realistic image generation, where we are creating faces, textures, scenes. Style transfer used to turn day into night or photos into Van Gogh paintings, medical augmentation to generate diverse data sets and rare diseases for rare diseases, and creative content from video game assets to fashion design. Right. So, did you know that AI powered image analysis can detect crop diseases week before they are visible to the human eye, potentially saving billions in agriculture losses? Here we are discussing about computer vision and image processing. Computer vision enables computer to see and interpret the images or videos. Think of it as giving computers eyes and brains to understand what they are seeing. And image processing techniques are used to enhance, analyze, and extract information from images. So we are using computer vision image processing in sustainability and automation in different ways. So here where things get visual, computer vision is the bridge between what human sees and what human can interpret. Imagine your eyes, but scale to 1000x speed and accuracy. So where do you think computer vision is more critical in healthcare, automation, or agriculture? Let's see some examples. So, how do these smart systems serve our bigger goals? Automation and sustainability. Generative AI is helping us to build intelligent technologies that can reduce waste, simulate better materials, and automate sustainable decision making. Automation is transforming the industries by enhancing efficiency, reducing manual labor, and streamlining operations, whereas sustainability focuses on minimizing environmental impact while optimizing resource utilization for greener future. And computer vision image processing drives smart, eco-friendly automation, enabling intelligent systems that improve sustainability and operational effectiveness. So, what's one challenge in sustainability you think AI could help solving? So, why computer vision specifically? Because automation without vision is blind. Vision gives machines the context they need to navigate, inspect, verify, and react. So, real time monitoring and decision making enables instant analysis of visual data, allowing system to respond dynamically to changes. It reduces the human intervention because we automate repetitive and labor intensive tasks and minimizing the errors and increase the productivity ultimately. And it enhances the accuracy and efficiency by improving the quality control, streamline the workflows, optimize the operations across industries like manufacturing, healthcare, and logistics. So, can you think of a task in your industry where seeing is the key to doing it better? So, there are a number of applications where we use computer vision. So I hope one thing is clear. Generative AI and computer vision are not just futuristic, they are transformative forces today. They help us move from automation to optimization to complete autonomy, all while building a more sustainable world. So let me ask you this, when we talk about automation, are we just talking about robots doing human work? Actually, automation is just the beginning. We are moving beyond the repetitive rule based task to optimization, where AI continually learns and improves the process. Real time quality control, smart scheduling, visual anomaly detection, they are not futuristic concepts anymore. Who here has been seen AI make a process more efficient in their own work or industry? So many of us have seen. Imagine a factory floor that corrects itself, a farm that adjusts watering based on a crop health, or a vehicle that reroutes based on traffic and energy usage. So these are examples of autonomous ecosystems. What's the key? Learning and adaptation. Systems that improve without manual programming. So let's hear from you. If you could automate and optimize one process in your day-to-day life, what would it be? Okay. So here is a cool evolution. We have a reactive. Reactive means you wait for a problem to happen. Predictive, you see it's coming and avoid it. Generative, you let AI design the system for sustainability and resilience from the start. So, one real world example, generative AI designing greener supply chains or sustainable city layouts. What would you trust on AI to design for you? Your travel itinerary, a new product, or maybe even your home layout? So let's go practical. Where does all this tech meet real world impact? In energy efficiency, waste reduction, cleaner logistics, even in resource conservations, AI and computer vision are rewriting the rule book. Think about your field. What's once unsustainable practice that AI could make smarter? Now let's zoom into real use cases. Detecting surface flaws in materials, monitoring crop growth, analyzing waste on conveyor belts. These aren't just technical applications, they are cost saving, time saving, and planet saving. Sorry. So here we have seen, we can see the first bullet, smart manufacturing. So smart manufacturing, where we are automatically detecting the defects by identifying product defects in real time to reduce the waste. Predictive maintenance, where we are monitoring the equipment health to prevent breakdowns and improve efficiency. In agriculture, we are focusing towards precision farming and crop diseases detection. Whereas in smart cities, we are most towards AI traffic management, automated waste sorting, where we are improving the recycling efficiency with AI powered sorting systems, renewable energy, where we are detecting the solar panel defects or wind turbine, we are monitoring the wind turbine, environmental conservation, where we are monitoring the pollutions or we can detect the forest fire. So let's imagine this, your workplace gets one of these technologies tomorrow. Automated visual inspection, predictive maintenance, autonomous robots. Which one do you think would make the biggest impact? Now let's break it down. Visual inspection is like giving machines eyes. AI powered cameras detect product defects instantly, faster and more accurately than human inspectors. This reduces the human errors and boosts quality control across the industries. Predictive maintenance means no more guessing when machines will fail. Using thermal imaging and computer vision, we can detect signs of wear before breakdowns happen. Thus, it saves time and money. Robotics and autonomous systems go a step further. From navigating factory floors to working in hazardous zones, AI-driven robots now handle repetitive or risky tasks. And we are not talking about replacing people. Today's collaborative robots or cobots actually work with humans. They handle the heavy lifting while people take on more meaningful, higher value roles. So, what driving this shift? Labor shortages, tech advances, growing demand for efficiency. Robots are now helping in logistics, pharmaceuticals, even hospitality, not just factories. Sure, challenges like cost and space exist, especially for smaller business. But as AI evolves and price drops, smart automation will soon become the norm, not the exception. So, if you had to choose just one, inspection, maintenance, or robotics, what your pick now? Okay. So what if you could fix a machine before it breaks? Predictive maintenance uses AI plus sensors plus computer vision to do just that. It saves money, time, and avoid accidents. Have you ever had a system failure that could have been avoided with smarter forecasting? Absolutely, you have heard. So, from self driving cars to warehouse robots and drone deliveries, computer vision and generative AI are transforming how we move goods and people. So, in self driving cars, computer vision detects the objects like pedestrians, vehicles, and obstacles in real time. It enables lane keeping by tracking road markings. It recognizes the traffic signs to adjust speed and behavior for safety. Automated warehouses where computer vision tracks the inventory, detect misplaced items, and monitors stock in real time. It automates package sorting by analyzing labels, shapes, and sizes. And it powers robotic picking, allowing machines to identify and retrieve specific items. Whereas drone delivery, here again we are using the computer vision which guides the navigation, helps in drones map surrounding and plot efficient flight paths. It supports obstacle avoidance, detect the trees, buildings, and other hazards in flight. So, which innovation excites you most? Self-driving cars, warehouse robots, and delivery drones. So, let me show you one example here. This is one of the example of a self-autonomous vehicle. It is a robot, or you can say a self-driving robot or a delivery man which delivers the food in Finland. So this is one of the most popular thing where I have seen that Finnish people are very excited for in Finland for delivery of their grocery. So this is just a glimpse. You can say this is a robot, self-autonomous robot, or you can say self-driven car, and it operates with the help of an app. So it delivers the grocery here, and with the app we open the box and we can take our product, and it just takes from here. So this is an example, a real-time example which we are using nowadays. So is also transforming how we move and how we manage the logistics. So computer vision lets machines see their environment, and generative AI creates simulated world to train them faster and safer. So imagine a waste collecting robots trained in thousands of simulated streets, safer, faster, and smarter. Would you ride in an autonomous shuttle or trust a delivery drone? So this is one of the most popular thing, autonomous shuttle I have seen here in Finland's universities, which is used by students to go from here and there by university students. So this autonomous shuttle is also one of the most popular thing which I have seen here. Let's tie this together. Computer vision flags waste as it happens. Generative AI redesigned the processes to produce less waste, like optimized layouts in text cutting. This is where intelligence meets impact. What's one area in your production or process pipeline that feels wasteful and could use a little AI help? So, who here have ever grown a plant, even just a little one by the window? Everyone, I hope. So now imagine managing thousands of acres with AI doing most of the work. So that's the smart agriculture where AI and computer vision comes together to transform how we grow, manage, and distribute food. So, precision farming, crop monitoring, disease detection is one of the most popular thing which we consider in smart agriculture, as real-time analysis from soil to harvest make it faster, data-driven decisions. Drones plus sensors capture the field images, whereas AI spot the diseases, pest, and nutrient issues early. AI controls irrigation, fertilization, pest control based on live data. Whereas generative AI for yield prediction suggests where, what, when to plant, improves planning and productivity. Targeted pest control has been achieved by computer vision because it identifies weeds, smart sprayers, and reduces the chemical use and protect the soil. And it also helps in tracking animal health, movement breedings, flag issues early in livestock by livestock monitoring. AI also predicts harvest volume and timing, reduces the food spoilage by doing optimization of supply chain. So imagine if your plants could talk, what would they say? Maybe I'm low on nitrogen or pest incoming. So with computer vision, crops can speak through visible signs. We can scan leaves for signs of pest, nutrient deficiencies or diseases. Then generative AI runs simulations to decide the best fertilizer plan or planting pattern customized per field. This saves resources and promotes sustainability. Who here sees this as a game changer in tackling the food security? If cities are living organisms, traffic would be the blood flow and waste the metabolism and energy the heartbeat. So let me ask you, how healthy is your city right now? Let's start with the traffic. A daily headache, right? So AI powered cameras can detect congestion and automatically adjust traffic lights. Less idle time is equal to fewer emissions. And with autonomous vehicles entering the scene, computer vision is their eyes and keeping everyone safer on the road. Public safety and security, now think safety. AI surveillance can detect unusual behavior, identify faces, and alert authorities instantly. Even street lighting can adapt based on foot traffic, bright when needed and dim when not. So, saving energy without sacrificing the security. What about keeping the city clean? Smart waste bins use vision to tell when they are full and call for pickup. No more overflowing trash. It also helps track illegal dumping and monitors pollution levels with image based air and water assessments. So in buildings, AI tracks energy usage in real time, identify where waste is happening. Computer vision even checks for dust or damage on solar panels to boost the output. And smart grids predict demand to reduce unnecessary power use. So planning a smarter city, satellite and drone images help design green spaces and detect infrastructure damage before it becomes a problem. So, if you could redesign your neighborhood, what would you change? Wider roads, more parks, less traffic. Computer vision analyzes the pollution, green cover, and traffic in real time. Generative AI then generates smarter city designs, reducing the emissions and increase the livability. These tools help urban planners simulate and compare multiple sustainable layouts before building anything. So would you believe that your trash can could one day be smarter than your phone? AI is transforming how we handle waste, from sorting trash automatically to designing products that never become waste in the first place. So this is the core of a circular economy where nothing is wasted, everything is reused. So how computer vision help? It scans and sorts with the help of camera, recognizes the plastics, metals, papers, even e-waste. It learns over time with the help of deep learning models to get better the more they see. And it makes decisions fast by identifying what's recyclable or not in real time. So imagine a bin that knows where your coffee cup belongs and gets smarter each day. So let's see some real world application. Let's talk about smart bins in public spaces or offices automatically sorting the waste. Recycling robots in plants sort materials faster and safer. City monitoring AI tracks waste levels to optimize collection routes. So some cities are already using AI to decide when to pick up your trash, saving fuel and time. So what are the key benefits here? It boosts the recycling rate without accurate sorting. It cuts the manual labor, reducing the exposure to harmful waste. It saves the money by streamlining operation, and it minimizes the landfill use, supporting the sustainability. But the cost of implementation in a, of it, implementing these advanced systems are not cheap upfront. The data quality which AI needs lots of good training data to be effective, and integration with IoT will allow real-time waste tracking, dynamic routing, and predictive analysis. So the future waste bins that talk to trucks, that talk to the cloud, that talk back to the city planners. So AI powered waste management isn't just about trash, it's about turning yesterday waste into tomorrow resources, smarter, cleaner, and truly circular. So, what if your next year was made from AI designed recycled plastic? Computer vision system can sort complex waste types, generative AI then models how to reuse these materials creatively and effectively, from recycled building blocks to durable customer products. It even predicts how long recycled materials will last. So let's start with a quick question in this slide. How much food do you think gets wasted in a typical supermarket every day? Would you believe it's over 30% in some places? Well, the good news is that AI is stepping in to help. Imagine smart shelves that can track freshness, alert staff before spoilage, and even drop prices automatically to move items before they expire. That's where computer vision and image processing comes in. Not just futuristic tech, but tools already transforming how retailers manage perishable goods. These systems monitor inventory in real time, analyze the camera feeds to detect aging or damaged products, and send alert when something is about to expire, allowing quick markdown or removal. AI also predicts demand more accurately than traditional methods. It looks um, you can say it helps stores avoid overstocking and running out. So dynamic pricing adjusts in real time to encourage faster sales of soon to soon expire items. It doesn't stop there. Image recognition now helps inspect food quality before it hits shelves, scanning for spoilage, bruising, or contamination. Think of it like having 24 by 7 digital quality control. Even consumers benefit directly. Mobile apps powered by AI can recommend recipes for items about to expire or offer deals on those products. So, personalized alerts help shoppers make smarter choices and reduce waste from their own homes. So, while these technologies are helping stores become more efficient and sustainable, just imagine having a fridge that did all this at home. Wouldn't that be amazing? So I'm just giving you a glimpse of another video. Ever scanned a fruit with your eyes and wondered, is this still good? Now imagine your phone doing it for you. So this is an example of smart shopping tool we are using here in Finland, which is powered by again computer vision to score freshness and suggest recipes based on expiry dates and even recommend personalized sustainable options. The idea is to make shopping more intelligent and less wasteful.
Look at this. Oh, perfect.
Just checking
Oh my
the
God.
ripeness of the
Isn't it
avocado.
great?
This
Chris,
machine
I
is
know, it's
checking
my
the
dream.
freshness score of
I
avocado
have
fruit.
goosebumps everywhere.
So they say water is the next oil. How are we treating it today? Computer vision and sensors can detect leaks, monitor water quality, and help with efficient irrigation. A helps plan water usage in smart cities, agricultural setups, ensuring every drop counts. How many of you think AI should be used to monitor water at home or offices? If a human can inspect 100 products in a day, how many can a machine do with computer vision? It's in thousands, right? So computer vision system detects defect instantly. Generative AI enhances training by generating countless variations of normal and defective products, making models robust. It's scalable, quality control, and fewer errors and high precisions. What if we had eyes on every forest, ocean, mountain, 24 by 7, warning us before disaster strikes? Imagine a world where computer vision and AI works around the clock to safeguard our environment by processing and satellite images, drone footage, and sensor data. These technologies detect wildlife, movement, pollution levels, early signs of environmental degradation, enabling us to act, not just react. The power of computer vision automates the analysis of environmental imagery and video with while deep learning improves accuracy in identifying patterns and anomalies. So neural networks process complex data, track changes over time, and eliminate the need for manual monitoring, making large-scale environmental surveillance both efficient and scalable. So wildlife conservation, like here with the help of these technologies, we can recognize and track species via camera trap images. We can detect illegal activities in protected zones, aiding anti-poaching efforts. We can analyze the satellite data to track glacier melt, deforestation, and ocean temperatures. We use AI model to predict climate trends and shifts. We identify air and water pollution through drone and satellite imagery to locate plastic waste in ocean cities for cleanup initiatives. It also enables early detection of wildfire, floods, and hurricanes to support emergency response with real-time analysis. With with these techniques, we can detect forest cover loss from satellite images, which reveals pattern of illegal logging and forest degradation. So real-time insights empower faster policy making and conservative strategies. But yes, the challenges are there: limited access to high quality labeled environmental data, high computational demands for large scale image processing, and privacy and ethical concerns in data collection and surveillance. So, future development will bring more advanced AI models, faster processing through IoT and edge computing, and strong collaboration between technologists and environmental experts. So, where would you deploy this technology first? Ocean, forest, or glaciers? After an earthquake, minutes can save life. So, how can AI act faster than humans? Can AI save us from the climate collapse? It just might help. AI powered computer vision is transforming disaster response, analyzing satellite drone imagery in real time to assess damage, locate victims, and monitor infrastructure. By automating these critical tasks, it accelerates decision making when every second counts. So, this allows for scalable, accurate, and cost efficient responses across diverse disaster scenarios from earthquake and floods to wildfire and hurricanes. Whether it's tracking rising water levels, detecting fire spread, or evaluating the structural safety of the building. AI makes disaster management faster. So advanced technologies helps in managing it more rapidly. So despite challenges like data quality, processing demands, and privacy concerns, the future of AI disaster resilience is promising. With continuous advancements, AI isn't just reacting to crises, it's helped humanity prepare for them. So let's play a game here. Raise your hand if you have taken a step to reduce your carbon footprint this week. No? So A is support that effort in every sector: smart agriculture, clean transport, green buildings, energy aware manufacturing. With computer generative AI, we don't just cut the carbon, we design systems that thrive sustainably. Would you trust a robot to assist your surgery or diagnose your condition? So AI is transforming the healthcare we all know, from medical imaging, from robot surgeries to early diagnosis, detection, and imaging. So admin processes, drug discovery, patient monitoring are all becoming smarter, faster, and safer. Which area do you think AI will impact most? Diagnosis, treatment, or prevention? So what do you do when real data is hard to find or ethically tricky? You generate it. So generative AI creates synthetic yet realistic data used for training AI models where real world samples are rare or sensitive. It's especially useful in medical imaging or rare event detection. How often do you think your electricity grid is wasting energy right now? So computer vision inspects grid equipment for faults. Generative AI helps balance load, predict demand, and optimize energy flow, keeping grid safer, greener, and more efficient. So we have explored how generative AI and computer vision are turning imaginations into actions, from farming and cities to healthcare and the environment. So this is just a glimpse of the things which we have discussed. So now let's kick things off with something real, because what better way to understand the power of AI than by looking at how it's transforming industries around us right now. I'm going to walk you through some fascinating case studies where generative AI and computer vision are not just buzzwords but game changers. So, have you ever thought about what keeps a wind turbine from failing mid operation? At Siemens Energy, they use computer vision to inspect turbines for micro cracks in real time. Something that used to take hours or even days. Now, it's reduced inspection time by 70%. But here's the cool part. Generative AI simulates airflow around turbine blades to find the most energy efficient designs. We are not just maintaining the equipment, we are redesigning it to be better. What if we could predict the wind? Sounds impossible? Not for Google DeepMind. They use satellite images with computer vision to monitor weather. Then generative AI steps in to simulate and predict wind turbine adjustments in real time. The result 20% boost in efficiency, that's clean energy, smarter. How do we tackle the plastic problem at scale? Plastic Bank uses computer vision to automate plastic sorting, but they don't stop there. Generative AI designs new recycled products and simulates how effective the recycling process will be. This approach has already diverted millions of kilograms of plastic from our oceans. So AI is cleaning up our mess, quite literally. So raise your hands if you thought AI was only for big tech companies. At John Deere, tractors are equipped with cameras that can distinguish between crops and weeds. Computer vision identifies them, and generative AI creates optimized spraying maps. So the impact up to 90% less herbicide use. So that's a win for the environment and for the farmers. Ever wondered how Tesla moves so fast? Tesla factories use computer vision to inspect every part of their battery lines. Meanwhile, generative AI simulates new battery designs for sustainability and performance. This combo leads to faster production with less material waste. It speeds with sustainability. So, of course, no innovation comes without its challenges. From data privacy to ethical design, we have serious questions to address like can we trust AI decisions? How do we integrate into older systems? The answers will shape the future. What's next? How do we push the boundaries further? We are stepping into some exciting directions reverse manufacturing, synthetic city environments, and climate digital twins, real time simulations of Earth to predict future events. Generative AI can even design eco materials and suggest how to meet environmental regulations. The future isn't just smart, it's sustainable by design. But we still have key problems to solve data privacy, interpretability, integration, and ethics. These aren't tech issues, these are human issues. And solving them will require collaboration across tech, policy, and society. So, where do you think your industry is on this roadmap? This slide is a timeline of transformation from 2020 basic automation to a future where we have self maintaining, smart farms, and AI regulated climate actions. It's not a question of if we get there, it's how fast we are getting there. So, what's on the horizon? AI systems that can process sensors, image, or text data all at once. Collaborative design between humans and AI. Fully autonomous green industries. Think ecosystems that are generative, green, and ever evolving. So, generative AI plus computer vision is next generation intelligence. We are shifting from simply reacting to actually predicting and designing a solution before problems even appear. So, it's more than smart, it's visionary. So let's bring it all together. Together, these technologies are moving industries from basic automation to autonomous ecosystems and from monitoring problems to designing sustainable solutions proactively. It's the evolution of intelligence and it's happening now. So here's the big picture. Computer vision and generative AI are not just enhancing the efficiency, they are rewriting the playbook on environmental responsibility and innovation won't stop. The road ahead is green, smart, and it starts with the choices we make today. So that's all about my presentation. Thank you. And these are some quality call for quality papers. Researchers are encouraged to submit high quality papers to their ongoing Special issues. So this is one of the special issues, empty sensor, IEEE JBHI, and TCE. This is again TCE. Thank you. I'm open for question now.
Okay, thank you, ma'am. So if you have any questions, the platform is open. So you can ask if you have any questions. Okay, I think, ma'am, considering the time limit, we have some, if you have some questions, so they will forward you with your email ID, if you permit.
Sure. Yeah, sure.
Okay, ma'am. So, ma'am has given very nice information about the generative AI. Also, the comparison between these two, generative AI and discriminative AI, and also explained nicely about the generative AI in detail. Also explained with the different examples with proper videos. I think it was easy to understand through the videos. So she has explained also applications of computer vision in sustainable automation and smart infrastructure, then predictive maintenance, autonomous systems, then transportations and logistics, then also about the recycling, robots and carbon footprints reductions. Also, different case studies he has explained. So this was a very informative session, ma'am. Thank you for your valuable time.
Thank you. Thank you so much having me here and giving me this opportunity. Thanks a lot.
So, with the permission of guest speaker, I would like to conclude this session for the first half of 17th April. I would like to express my gratitude and vote of thanks to all the participants, faculties, and research scholars, and the organizing secretary as well. I would like to specially mention the conference convener, Dr. Narendra Soni Sir, Principal of VPM's Maharshi Parshuram College of Engineering, Vanishwar, for his continued support and encouragement. Then our chief guest, Dr. Ankur Gupta sir. Then our keynote speakers and the concluding session by Deepika Kondal ma'am, which was very informative. I thank all the participants, coordinators, organizing partners, also by the Dr. Batu, which is the organizing partner in STM journals. So thank you all participants. The next session will start at 2 p.m. today. So please join on time. Thank you so much, everyone.